Hi, today we will test the continuity of our function with the limit method, and the first example is fx equals x multiplied by sine 1 over x. So in this function, the 1 over x is not defined at x equals 0 because we can't divide by 0. That's why it's removable discontinuity. The second one is fx equals to sine 1 over x. It's the same thing, it's again discontinuity at the point x equals 0. The third one is fx equals x. The x is the all integer numbers, and this function is always continuous because what value x gets, the same value fx is getting. So this function is continuous always. The d1, it's fx equals x squared if x is irrational, and 1 if x is rational. So there we indicate our points. So fx here, fx is 1 at x equals to plus or minus 1, and these are points of our continuity. So for all other points, they're all discontinuous points. These are continuing points. The e example is fx x squared plus 2 over x cubed plus 1. Again, x cubed plus 1 cannot be equal to 0. X cubed cannot be equal to minus 1. And x cannot be minus 1. And this is our point of discontinuity. There will be a graph. So there minus 1, or there's our vertical asymptote. The graph goes this, and if it's our parabola, it goes like this. So then the f example, it's a fx equals arc tangent 1 over x, and we know this value 1 over x is should be between minus infinity till plus infinity. But however, the x cannot be 0. So at the point x equals to 0, it's a discontinuity. It is continuous. The g example, it's a fx 1 x divided by 1 minus x. So 1 minus ex divided by 1 minus x cannot be equal to 0. And there's two ways. There's two points. The first point is 1 minus e0, 0, so x is 0. And the second one is 1 minus x cannot be equal to 0. That's why x cannot be equal to 1. So we get 2 points. It's 0 and 1, and it's our discontinuity points. Then our h example, it's fx x cubed ln x cubed x plus 1 multiplied by x minus 3. So x plus 1 multiplied by x minus 3 cannot be equal to 0. X cannot be minus 1, and it's 3. So there are our points of discontinuity. And if we graph, so this 3, and it's our vertical asymptote, and it's our minus 1, it's our vertical asymptote. So it goes like this and this one. The I example is that fx equals to x cubed for x less than 1 and equals or bigger than 0 to minus x for 1, x, and 2. So here we see 1, the 1, and that x equals to 1 is not defined. Therefore, point of our discontinuity will be 0 at x0. So if we graph, it's our parabola, and it goes in the interval. So it's our parabola, and then it's our second function. So this is our parabola, and it's our second function to minus x. The g example, it's fx equals to x for less or equals to 1 and 1 for x bigger than 1. So if we graph this functions, so when x is bigger than 1, we get the y value is 1. So it gets like this, but it's in the model, so we can plug in the negative numbers, and we can plug in -1, and it can go from the left hand side. So that's our -1, and this is our 1. So this is y equals to 1 function. Then there's a first function, and this function is, so x less than or equals to 1. So we start from there. It goes like this. So as we can see, uh, our continuity interrupts here at the point -1, and it's go down from there. So it starts like this. So at -1 point, our continuous interrupts, and x equals to -1 is our discontinuity point. And the last example, k, it's a fx, so cosine px or 2 for x less or equals to 1, and x minus 1 for x greater than 1. So if we graph this, first we graph the cosine function. It's from -1 till 1. It goes like this. So it's our cosine function. And if we graph our second function, x minus 1, it goes from there and there because it's model. So as you can see, our function is interrupted in point -1. So we came here, and then our function is interrupted, and we get this cosine function. So x equals to -1 is our discontinuity point. So our graph shift from there. That's why x minus 1 is our discontinuity point. Thank you for watching.